We're going to multiply using an area model. We're going to multiply 106 times 21. And in an area model, you're using rectangles, and in these rectangles, the area inside is supposed to represent the multiplication of the base times the height or the length times the width of whatever the sides are. Now I have 106, so I want to represent each portion of the 106 using three different rectangles. 100 is one portion. The tens digit has nothing, and then there's 6 units here. So I have 100, 0 tens, 6 single digits. And then 21, I'm going to represent 20 and 1 on the side. So you break each individual place value of tens into its own section. And then I multiply. 100 times 20 is 2,000. Nothing times 20 is nothing. 6 times 20 is 120. 100 times 1 is 100. Nothing times 1 is nothing. And 1 times 6 is 6. And then I add these values up. That is 2,000 plus 100 plus 120 plus 6. So that is 2,226. Next, we're going to use lines and intersections to multiply 213 by 31. For each different place value, you want to represent by that many lines. So for instance, for 213, I represented that in green, and I represented 31 in blue. The first 2 lines represents the 2 for the hundreds, the next line represents a 1 for the tens, and the 3 is represented by these 3 lines. And then the 3 blue lines horizontally are representing the 30, and the 1 represents the 1 in the single digit here. Now what I do is I count up however many intersections there are between the blue and the green for each of the different times that they hit each other. And I'm going to write each of those values down. That's 6, 3, 9, 2, 1, and 3. And then to hold my place value, I add all of these at a diagonal. I start here. This is 3. I add the 9 and the 1. And the 9 and the 1 becomes 10. But because I'm in base 10, anytime I have a 10, I need to carry over. So I'm actually going to carry over this 1 to the next diagonal. So I have 3 plus 2 is 5, plus that extra 1 is 6. And then I have 6 here. And so my answer is 6,603. Notice that I took the ones digit of the 10 as that value for that placement, and then I carried over the 1 into the hundreds. Finally, we're going to multiply using lattice method. Lattice method also uses rectangles similar to the area model, but there are diagonals to help us divide when we have a placement for more than just a single digit. I'm going to multiply 1,483 by 273. I'm going to put the 1, 4, 8, 3 on the side because I have 4 rectangles there, and 2, 7, 3 on top because I have 3 rectangles or 3 columns there. So the 4 rows represent 1, 4, 8, 3, and the 3 columns represent 2, 7, 3. And then I multiply each of the individual pieces. 2 times 1 is 2. I put a 0 in the upper portion because that represents the tens place. 1 times 7 is 7. 1 times 3 is 3. 2 times 4 is 8. 4 times 7 is 28. So I write the 2 up top and the 8 down low. Tens digit up top, ones digit down below. 3 times 4 is 12. 8 times 2 is 16. 8 times 7 is 56. 8 times 3 is 24. 2 times 3 is 6. 7 times 3 is 21. 3 times 3 is 9. And now, using the same approach that I had before in the lines and intersections, I'm going to add a diagonal. And it's nice and cleanly listed for me what the diagonals are. I'm going to be adding each of these diagonals to represent its own place value. So I have 9. 4 plus 0 plus 1 is 5. 2 plus 2 plus 2 is 6. Plus 6 plus 6 is 18. So I have 18 here, but I'm going to record the ones digit and I'm going to carry over the 1 to the next column. I have 1 plus 3 plus 1 is 5 plus 5 is 10 plus 8 is 18 plus 6 is 24. I'm going to record the 4 for the ones digit. I'm going to carry over the 2. 2 plus 8 is 10, plus 7 is 17, plus 2 is 19, plus 1 is 20. Recording the singles digit, carrying the 2. 2 plus 2 is 4, and I don't have anything to carry over. The last one is 0. And so my number is 404,859.